Hey guys, this is Miss Went, and I wanted to go over the lab that we got the data for yesterday. So it's the back page of your Chapter 5 packet called What's the Power on Your Stairs? Because when we find power, watts is the unit we measure them with. So the learning goal for this is we wanted to calculate work and power of you moving on the stairs. So we went to the gym. You measured the height that you were walking, and you walked up the stairs, and then you ran up the stairs. So we have two different times. Everybody did their own thing, and that's what we got. So before we went, we figured out that your independent variable was the speed. So sometimes you walked, sometimes you ran. Dependent variable was the time, but we're going to use that time to calculate the work. So really, work is our dependent variable. We just have some math to get there. Constants are all the things you did the same going up and down the stairs. And the control, usually people are going to walk up the stairs. They are not going to run. So I would recommend walk as your control. Okay, so we went to the gym and we got our data. Now everybody's going to have different data. So I'm going to make up numbers. You should not copy my numbers. Don't copy my numbers, okay? I'm going to pretend my stair height is 10 meters. That is a ridiculously tall stair height for our gym, so don't copy that. I'm going to pretend that I walked it in 30 seconds and that I ran it in 10 seconds. Don't copy my data. It's not your data, okay? Now, in order to figure out my work, I need to know what's the force that I'm working against. And that's gravity pulling me down. Now I'm going to pretend that I weigh 100 pounds. I do not weigh 100 pounds, but we're going to pretend that for today. Okay, so my weight in pounds, and if I want to change that to newtons for the metric system, which is how all these formulas work, I need to multiply this by a factor of 4.5. All I'm doing is changing pounds from the English system to newtons in the metric system. And 100 times 4.5 will give me 450 newtons. My pen's being a little weird. So, but 450 newtons. Now, this is the force of gravity pulling me down. So I am going to use 450 newtons as my force for all my math, because my weight did not change during the lab. So that's going to stay a constant, was my weight during the lab. All right, so here's the math I'm going to do. Now, again, my numbers are different than yours. Don't copy my numbers. You have to use your numbers. Okay, but the formula for work is force times distance. So when I was walking up the stairs, my force, use my finger here, my force is gravity pulling me down, so I figured out that was 450 newtons. And I need to multiply that by the distance. So my distance I made up was 10 meters. So my work was 450 times 10, which would be 4,500. And work is a transfer of energy, so my unit is going to be in joules. Okay? Now, to find my power when I walked up the stairs, I'm going to take this same work that I just figured out, and I need to divide it by how much time it took. So my work, which I got from the problem above, and divide it by how much time. And I said that when I walked up the stairs, if I look at my data, it took me 30 seconds to walk. So I'm going to divide this by 30. Okay, 4,500 joules divided by 30 seconds is going to be, I believe in my head, 150, and power is always measured in the unit watts. So it took 150 watts of power for me to walk up that staircase. Okay, now if I'm going to do the same thing over here for running the stairs, now the work for when I'm running, work is still force times distance. My weight did not change, so that's still going to be 450 newtons. And my distance also did not change. It's the same staircase. So I noticed that I'm going to end up with the exact same amount of work no matter if I walked or ran. It doesn't matter how fast you do the work. It's still the same amount of work. Okay, yesterday I talked about cleaning your bedroom. It doesn't matter if you clean your bedroom really fast or if you mope around and take 6 hours to clean it. It's still the same amount of lifting things off the floor. The amount of lifting stuff doesn't change no matter how fast you do it. So the work is going to be the same. That's a really big idea from this lab, is that time doesn't matter when you figure out work. However, we do use the time in our power formula. So when I was running up the stairs, I did the same amount of work as when I was walking, but I used less time. I used 10 seconds of time to run. 4,500 divided by 10 would be 450 watts of power. So I was more powerful running than walking. That makes sense. But it doesn't matter how fast I go up the stairs, it's the same amount of work. So you have some questions to answer that goes along with this math here. And when you're finished doing the math with your numbers and with the questions, you should look over your whole packet, see if you have any math questions, and get ready to hand it in. Okay? Real quick, I also wanted to show you, this is what's going to be on your test tomorrow. You're going to have some vocab words from Chapter 4. There is stuff on Schoology to help you with that. The work and power vocab from Chapter 5. We did not do all of Chapter 5. We just did the first part. So all the stuff about machines you can skip. We had 4 math formulas: kinetic energy, potential energy, work and power. We talked about how they change in different things. And then there's a whole bunch of resources there to help you to study in Schoology and stuff like that. Now, we also, we did not do this math quiz. You guys are doing so awesome with math, we just skipped it. But you did have an energy packet, you did have a work packet, you got the book, you got stuff on Schoology, and you're going to get a new review sheet now from the teacher. And the answer key for that will be in the back with Miss Tripp and Alicia. So when you're finished, you can kind of check your work as you go. And then you're going to play a review game towards the end of class as well. So please get your lab done and turned in, and then start working on your review. Have a great day. I'll see you tomorrow.